a secret for all agree. Everywhere I go, it's guys on me. Just you and me, singing together. Boys just wanna have fun.
I keep on singing my melody. Everything I do, and my magia. Just you and me.
To ensure our design will work in practice, we've conducted a preliminary analysis. We have applied our design onto a prototyping board. This will allow us to analyze our design in action and allow us to observe the results, such as design malfunctions, component errors, and output variation. Additionally, using a breadboard allows us to take into account the variables that are not in the simulation, such as heat, component size, and component malfunctions. The steps we took are: first, gather the needed lab materials. Second, set up the prototyping with the needed parts. Third, start the experiment. And lastly, record the data from the experiment.
The basic building blocks of a regulated DC power supply are the transformer, rectifier, filter, and regulator. The AC voltage source supplies the transformer, wherein the transformer steps down the input AC voltage by means of lowering its value through a certain conversion ratio. The step-down voltage enters full bridge rectifier and rectifies a step-down AC voltage into a unidirectional pulsating DC. The rectified voltage now enters the capacitor input filter. The capacitor input filter smoothens the rectified voltage to produce an almost constant DC value having very less ripple content. The filtered DC voltage will go through the process of voltage regulator to maintain a constant output voltage despite changes in the AC main, current load, and temperature. With the explained block diagram, the group, together with their mentor, has decided to use a simple schematic diagram for the power supply. It only needs 4 diodes, 3 capacitors, 1 regulator, 1 resistor, 1 trimmer, and 1 potentiometer.
During the process of making the project design, the group has encountered constraints and is able to handle it successfully. The group's main constraint is to produce a 2 to 25 voltage output, but using a trimmer, it produces a closer required range. Another constraints are the limited PCB, prototype layout design, the spacing of regulators, and also the time constraints. Another concern of the group are the set of standards that has followed in order to have a safe prototype output. The group's safety requirements are the flammability, maximum temperature, electrical tracking, heat deflection, and the direct support of live electrical parts. The group used the PCB safety standard UL796 law as their basis in achieving some standards. It might affect the project design. Along the PCB law are the printed board dimension and tolerances, the generic standards on printed board design, the acceptability of printed boards. These are the laws to consider in making the PCB output.
Planning the objective and procedure that the researcher will use to help them make an adjustable power supply with a voltage output range between 2 to 25 volts. The design should work in breadboard or in any virtual stimulation, and when the design is working in breadboard without any components being damaged, print the design in the PCB and transfer the components from the breadboard to PCB. And see if any damage is done when you try it in PCB. And then put it in the case and make sure the components are secure inside the casing.
According to George Gobel, if it weren't for electricity, we'd all be watching television by candlelight. We live every day with ease because of these machines, electronic devices, appliances, and gadgets that are available at our generation today. These mechanisms need electricity to operate for our daily use. With that statement, we can say that electricity is very vital to us. With the rise of fast-paced technologies, we cannot progress without electricity. To conduct electricity from electric companies to our houses, long range of distances are needed to be transmitted. This electricity is available at our electric sockets, producing 220 volts AC. Alternating current can convert voltage levels with a single component, and for that reason, it is chosen to be the primary means to transmit electricity. That is convenient for transferring electricity to long distances, but most of our digital electronics today use direct current. In order to produce DC voltage, we need a power supply that will convert AC voltage to DC voltage. With the current dilemma of converting AC voltage to DC voltage, we came up with creating a project design of a power supply that will convert the voltage from an electric outlet source to range of voltage an electronic device needs. This power supply will produce voltage within the range of 2 to 25 volts that can be varied depending on the needed voltage output. Thus, this project design will be beneficial to our society today.